3 simplest machine learning projects that helped me learn the foundations and basics of ML. All of these examples use real-world data and could be applied in real life, so let's break it down. First is a linear regression model to predict how many points a basketball player will score in their next game. Take a look at this example dataset. Here, columns A, B, and C are the input columns, while X is the output column. Using a dataset of this format, a linear regression model draws a line of best fit through your data by deciding how much each input column actually matters when it comes to predicting the output. We've all learned about slope-intercept form, y equals mx plus b, where we try to find the right y-intercept and multiply x by the right value to get the perfect equation. This value that we're multiplying x by is called the variable's weight. For this example, I'm using this dataset from Kaggle. We start by loading our data and cleaning it up. Now it's time to split our data into 2 categories: training data and testing data. Training data is what helps the model learn the weights that we talked about before and actually create the equation that will draw the line of best fit. The testing data is top secret for now. The model should absolutely never see it in its training stages. We'll use it later to test the model and see how well it works on unseen data. Now it's time to feed the inputs from the testing data to the model for the very first time, and we're asking it to predict the outputs to these inputs. Afterwards, we evaluate it with something called mean squared error, which basically measures how close the line of best fit is to the data. Once we have the line drawn, it's really easy to see what any given x value would output, and we've successfully completed a linear regression model together. This is a machine learning model that you'll quickly grow out of as you learn more, but it's a great place to start, so you can find this full example code at this link. Next is a logistic regression model to decide if an email is spam or not spam. Whenever we're trying to predict a category in machine learning, we're doing a classification. We could, in theory, also run a decision tree here, but since we only have 2 classes, spam and not spam, we're sticking to logistic regression. However, I highly encourage you to delve into decision trees and random forests as well. With this example, we're starting with data that has a bunch of labeled emails. I'm using this dataset from Kaggle. We import our libraries and load in the data. The model weights the inputs kind of like the linear regression model, where it decides which inputs have more value and which have less. First, it decides on a baseline, or the constant in an equation, and then it multiplies each input by its decided weight. It adds everything together, and this final sum is called the logit. This sum will help us run the regression, but before we do that, we're using something called a TF-IDF. This vectorizer turns text into numbers by counting how often each word appears in a document. Then it shrinks the weight of words that appear in many documents, so rare informative words stand out and common filler words will fade. Afterwards, it passes the logit sum through a sigmoid function that turns the logit into a probability between 0 and 1. Remember that in logistic regression, the sigmoid function is fixed, so it's always the same. Now think of the model's output as a spam score between 0 and 1, like a percentage. During the training stage, the model practices on labeled emails and learns to give spam higher scores and normal email lower scores. After that, you choose a cutoff to turn the probability into a yes or no decision. For example, call it spam if the model says 0.8 or higher. If you hate false alarms, move the cutoff up so that only very high probabilities count as spam. But if you hate spam in your email inbox more, then move the cutoff down so that more emails get flagged as spam. That cutoff is the single knob that makes the filter stricter or more forgiving. Here we're using the default threshold of 0.5. Now we judge the model's performance on metrics such as precision, recall, and accuracy to get the results. Lastly, we use our testing data to get predictions for inputs that the model has never seen before, and here is what we get. Third is a k-means clustering model to group shoppers by their shopping habits when we have unlabeled data. K-means clustering is an unsupervised machine learning model that groups your data into k clusters based on the similarity of points. I'm using this dataset also from Kaggle. We begin the model by importing our libraries and loading the data. The model begins by placing k initial centers, often with k-means ++ so that the centers begin far away. Each data point is assigned to its nearest center. We measure how near a data point is to a center using Euclidean distance, which is just the direct straight line distance between 2 points calculated with the Pythagorean theorem. For each data point, we measure its distance to the center and square that value. We do this for every data point in every cluster, add them together, and this is the sum of squares. Many libraries also call this number inertia. One of the most important things to understand is that as our value of k increases, inertia will always go down, but it does so with diminishing returns. Then we plot the amount of clusters versus inertia to see where adding more clusters doesn't lower the inertia very much anymore. This is the elbow of the graph, and we just completed the elbow method. You should always choose k at or just before this elbow bend, as this is the point that facilitates most of the possible reduction in inertia without overcomplicating the clustering. There are a variety of other strategies to choose K, such as the silhouette score, which I've broken down in my last video. Once we have finally chosen K, we run the model itself and then summarize the clusters. Make sure you save this video for the next time you decide to try a simple machine learning project and follow for more.